Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So friends, first of all, as on your screen, an unbalanced reaction is being mentioned, and what you are going to do is you have to balance it. So first of all, let us see that the atoms rather than oxygen and rather than hydrogen are being balanced or not. So in this case, the silver molecules or silver atom is being balanced because 1 mole of silver is present on the reactant side, as well as 1 mole of silver in the form of iron is present on the right hand side, that is on product side, while that of nitrogen, which is not an oxygen and not an hydrogen atom, so this is also present in 1 moles while in reactant side, while again the number of moles of nitrogen on the right hand side, that is on the product side, is also 1, that is the both are same. So we don't have to balance the atoms of nitrogen and silver in initial state. So the first stage or the first step that we are going to do is we have to determine the oxidation number or oxidation state of the atoms which are present in reactants as well as present in the products. So let us do it. We are starting with step number 1. So I will name it as you know that I will name it as determination of oxidation number. So in this case, the oxidation number of Ag in reactant side is 0 because there is no presence of charge, either positive or negative, present on the silver atom. So therefore, the oxidation number of Ag is 0, while that of NO3 we have to calculate. So for that, I can write in this way: the oxidation number of NO3 minus is -1, or I could write it as 1 minus. So now we are going to do is we are going to evaluate, or we have going to determine the oxidation number of nitrogen in NO3 minus. So for NO3 minus, I could write it as 1 times of nitrogen plus 3 times of oxygen, which has an overall charge of 1 minus, or you can write it as -1. And I don't know the oxidation number of nitrogen in this case, so therefore I have taken it as X, plus 3 times of oxygen has an oxidation value or oxidation number as -2. So this will give you an answer of -1, and this will be multiplied by +6. This will be multiplied by -2 in this case. So -6 will be +6 when it shifts from left to right hand side. So therefore X is equals to 5. Therefore the oxidation number of nitrogen in NO3 minus is 5 plus. So we have estimated the oxidation number of reactants. Now the products are being left, so we are going to shift towards that one. So in product, as we can see that the products are Ag plus. So therefore for Ag plus, the oxidation number will be of Ag, that is for silver, in Ag plus is 1 plus, and therefore the oxidation number of nitrogen in NO2 will be. So first of all, we have to write, or we have to mention it very clearly, that the oxidation number of NO2 is 0. Therefore I could represent this NO2 as 1 times of nitrogen plus 2 times of oxygen, and the overall charge is 0. Therefore we have to estimate the oxidation number of nitrogen. So plus 2 into -2. So therefore X will have a value of 4 plus, or I could write it as 4. So from this case, eventually I have estimated that the oxidation number of nitrogen in NO2 is 4 plus. So this is how we have calculated the oxidation number of the atoms present in reactant as well as in products. So now we are going to check whether the reaction is oxidation is occurring through oxidation as well as reduction. Means the overall reaction is reduction. Means the overall reaction is redox reaction or not. So let us find it out. So the reaction that was being mentioned was Ag plus NO3 minus, that have given us Ag plus NO2. In this case, the oxidation number of Ag was found to be 0, while that of the nitrogen present in NO3 minus was found to be plus 5. While in this case, for Ag plus, the oxidation number is 1 plus, and while in case of NO2, the oxidation number of nitrogen is found to be 4 plus. So what we are going to do is we are going to compare the oxidation number of the atoms. So in this case, what I have observed is the oxidation number of silver. The oxidation number of silver is been changing from 0 to 1, which means electron is been lost by the silver molecules and or the silver atom, then only it has converted into Ag plus, means the oxidation number has been increased. So this is only possible in oxidation reaction. So therefore this will be an oxidation reaction. Let us check the other one. It would be a reduction, but let us see and let us confirm ourselves. So in this case, as we can see that the nitrogen has the oxidation state of 5 plus, is been converting into 4 plus. This means electron would have definitely accepted by this nitrogen or this nitrogen molecule, this NO3 minus molecule, then only it has converted from plus 5 to plus 4. So because electron has been accepted or electron has been gained, so this is a reduction process, and hence we have confirmed that the given unbalanced reaction is a redox reaction. So now what we are going to do is we are going to check whether the electrons are being balanced in this reaction or not. So the second step would be step number 2 will be balancing electrons. So first of all, let us check how many number of electrons are being lost during oxidation. So the number of electron lost during oxidation, we'll compare this with number of electron gained during reduction. So let us take the reference of the last balanced equation that we have estimated, which was found to be this one. As you can see, to convert the oxidation number 0 to 1 plus, the number of electrons that have lost will be 1, while the number of electrons that this 5 plus will accept, or this oxidation, when we are going to change the oxidation state from plus 5 to plus 4, then the electrons that would have been accepted, the number of electrons would be 1. So in this case, the number of electrons that has been accepted and the number of electrons that has been donated, the both are 1. So as we can see, the electrons are being balanced. So no need to multiply or no need to cross multiply. So it's very simple that we can move towards the next step. It was one of the most easiest numerical or easiest equation that we are solving. So let us move on. So let us move towards the next step, that is step number 3, in which we will balance the oxygen atoms. So in step number 3, we will balance oxygen atoms. So first of all, we have to check whether the number of oxygen atoms on left hand side is equivalent to number of oxygen atoms present on right hand side or not. So taking an preview of the last balanced equation, we got to know that the number of oxygen atoms on the left hand side, that is on the reactant side, is 3, while that of the number of oxygen on the right hand side, that is on the product side, is 2. So number of oxygen on left hand side, that is 3, while that on right hand side is 2. So how many mole of oxygen atom is deficient and where? So there is only one oxygen atom which is less or which is deficient on the right hand side, that is on the product side. So friends, the number of oxygen atom on the right hand side was found to be 2. Now what we are going to do is we are going to balance the number of oxygen atoms on the right hand side. So since the deficiency of oxygen atom is 1 on the right hand side, therefore we will add 1 mole of H2O on the right hand side, that is on the product side. So therefore what we could get is, this was the initial equation that we have balanced, which was Ag plus NO3 minus, that has given me Ag plus and NO2. So what we are going to do is we are going to just add 1 times of H2O or 1 mole of H2O on the product side. Therefore the answer that we could get is Ag plus, that is silver, plus NO3 minus, that will give us Ag plus NO2, and since we are adding H2O on the right hand side, that is on product side, so we'll get H2. So this is the balanced reaction of step 3 of oxygen atoms. But this is not over yet. We have to balance the hydrogen also, which has been generated in this equation. So the step number 4 would be balancing the hydrogen atoms. So on left hand side, the number of hydrogen atoms should be equal to the number of hydrogen atoms on right hand side, that is on the product side. So this was the earlier equation that was being balanced with the oxygen, which contains 0 number of hydrogen on left hand side and which contains 2 number of, that is number of hydrogen that is present on the right hand side, that is on product side, is 2. So therefore I could write it as 0 and here I will write it as 2. So there is deficiency of hydrogen atom, but on which side? On reactant side. So therefore what I'm going to do is I'm going to add 2 times of H plus on the left hand side. So therefore adding 2 moles of H plus on left hand side, we get Ag plus NO3 minus plus 2 times of H plus, that should give us Ag plus NO2 plus H2O. So this is the final answer that we have got, or this is the final balanced equation that we have predicted in acidic medium for a unbalanced reaction. So it was so much simple to calculate the oxidation number as well as to balance the overall reaction in an acidic medium. So thank you friends for watching this video. I hope we have got the concept clear how to balance this unbalanced equation. So share this with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.